Hello everyone, welcome back to Think Lab by Saurabh. So today we are going to understand one of the most important architecture in generative AI we call the GAN, Generative Adversarial Network, right? So GAN stands for Generative Adversarial Network. So in this tutorial we will not simply discuss the theory, we will start from the foundation, then we will understand the generator, then we understand the discriminator, and we also understand how GAN training works, and finally we will build and train our own GAN using the Python and TensorFlow, right? So by end of this video, we will have complete understanding of how can GAN learn to generate the new images, right? So first thing is the what is a generative AI? So before understanding the GAN, so let's understand the generative AI. So traditional machine learning model usually learn to predict the something. For example, given a image, a model might be predict whether the image contain cat or dog, right? But generative model work in a different way. Instead of only predicting the existing classes, a generative model learns to underline the distribution of the data, right? After the learning that distribution, it will create a new sample. For example, if you train the generative model using the thousands of handwritten digit images, right? So the model can learn the pattern of those digits, and it can generate completely new digit that did not exist in the original data set. So this is a basic idea behind the generative modeling, right? So now we are talking about the GAN. So GAN is just introduced by Goodfellow in and with his colleague in year of 2014. So the key idea behind this GAN is extremely interesting. So instead of using the one neural network, we use two neural network here. The first network is called generator. Another second network is called the discriminator, right? So these two network compete with each other. So this competition is why the architecture is called the generative adversarial network, right? So adversarial network, we now we are to try to understand the what is the intuition behind this GAN, right? Generative adversarial network. So let's understand by using the simple example, right? So uh, imagine the generator is an artist, right? So generator job is to create a fake image. So now imagine the discriminator is an art expert. So the discriminator jobs is to just to determine the whether an image is real or is something generated. So we have a two players, so generator versus discriminator. So then the generator try to fool the discriminator, and discriminator try to not get the fooled. So this create the adversarial learning process, right? So this is a very interesting thing here, generator and discriminator. So the game is going on, and we have to check the adversarial learning process, right? So now we have to understand, real and fake data. Suppose our data sets contain the real handwriting digits. So the image are passed to the discriminator. So at this stage, the generator create a fake image, right? After that, after that fake image are also passed the discriminator, and this discriminator process the probability, right? Produce some kind of probability right here. So if the image is real, the output should be close to 1. If the image is fake, the output should be close to 0, right? So now we are trying to understand what is the generator, right? So let's focus on only the generator part. So generator start with the random noise. So usually we call the random vector as a latent vector. For example, we can generate a vector containing the 100 random number. So this vector doesn't look like an image, so it's simply random point in the latent space. So the generator take this random vector as an input, and those several neural network layers, so it transform that the random vector into the image. So we have a concept, we have a random noise, and then we have generator, and we have to finally generate the images, right? So till now we have understand in the generator random noise, then we generator, and the generated image, right? So now we are moving to discriminator. So let's understand the discriminator. So discriminator is essentially a binary classifier. So it's receive an image. So that image can either be real from our data set, or it can be fake image created by the generator. So the discriminator output is the probability, right? Probability. So close to 1 means real, close to 0 means the fake. So the generator wants discriminator to output one of the fake image. So but the discriminator want to correctly identify those images are fake. So this create a adversarial relationship, right? So now we have to understand how the GAN training works. Okay, so let's understand the most important part is training. So we don't train the discriminator and generator in the exactly in the same way. We train the discriminator, it we give the real image, then tell it to that these are the real image, then we generate the fake image using the generator, and we tell the discriminator to these are the fake, right? And after that we update the discriminator. Next time we train the generator and we generate the fake images, right? We pass through the discriminator, but this time we want to discriminator to believe that the generated images are real. So therefore generator learn to produce realistic image, right? So let's explain the objective in this video. So original GAN objective can be written as the mean max optimization problem. So discriminator try to maximize this ability to distinguish the real and fake data, and the generator try to minimize the discriminator ability to distinguish them, right? So you don't need to memorize the mathematical equation immediately, right? So if you check the important intuition in this whole concept, so discriminator identify the real versus fake, generator creates the fake sample that looks real, right? Both network improve through the competitions, right? So now we are going to, so let's move to the theory to implementation. We have learned the theoretical things like what is a discriminator, what is a generator, what is a GAN. So now we are going to build one of the type of GAN we call the DC GAN using the TensorFlow and Keras. And our data set will be the handwritten data set. So MNIST contain the grayscale image of handwritten digit from 0 to 9, and the image are the 28 by 28 pixel, and using the MNIST keeps the project computationally simple, and that allow us to focus on the understanding the GAN architecture, right? So now we have to start with the coding part. So we have already opened the Google Colab. So we are going to import the few libraries, because this library is required. First we have to import the TensorFlow, then TensorFlow provide the deep learning framework. We have to also use the NumPy here for the work with the random arrays and this random noise. Matplotlib that will generate the images, and OS that will manage all the files, right? So let me write here I'm going to write these things. So we have written TensorFlow as a TF, right? We are importing the NumPy and Matplotlib. Okay, everything we are written here as we discussed. So and the OS will manage all the files. Once we complete these things, so now we have to checking the TensorFlow version, right? What is the current version here, right? So we have to check because for this creating the GAN we have required the GPU. So we have to also checking the whether the Google Colab provided us the GPU or not. So for the checking part we have to write the code, right? So I am going to write here for the checking part. So it will take some time. So for education it will take the time, right? So it's still working. Okay, so okay, let me write here. It will take some time to just execute the. So we have to also check the TensorFlow version, right? Now this first cell is executed successfully. So we are going to test the TensorFlow versions, right? And also that we have to check the GPU available. So you can see here the GPU is not showing here, right? So we have to configure our GPU devices. So for GPU you have to go into this runtime, right? You have to come to here this manage sessions. Okay, fine. We have to come to the runtime, and we have to just change here the runtime type, right? So Python 3 is there. Now we have to select this. We have this kind of EPU. We can also select this TPU, but we have a T4 GPU, right? So we are going to just use this TPU, right? And we are going to click here the save, right? Now let me run these things because we have selected the GPU, so it will execute all the code very fast, because now previously we have used the CPU only. Now we are going to use the GPU, graphic processing unit, right? After that, once we run this code, so it will also show the GPU configurations. What is the GPU configuration here, what kind of GPU we have in Google Colab. So let me run these things. Okay, so you can see here now this TensorFlow is even, and GPU available. So you can see here the GPU device name is given, right? So we got this. So now we have a GPU, right? So for the small data set again, so CPU can work, but GPU will make training faster. So that's why we are using. Once we complete those things, so now we have to use this MNIST dataset. So MNIST dataset is already in the Keras. So we can directly write the code, from the taking the dataset from the Keras. So once you run these things, right? So you can say we got here the MNIST dataset, right? So this is the MNIST dataset inside the TensorFlow. So we simply write the dataset, the MNIST load the data, right? So we got the data. So you can see here the size is the 60,000 and the size is 28 by 28, right? So we loaded the MNIST data set, and we don't actually need to digital label. So this is important. GAN is not trying to classify the digit into the classes. It's learning the distribution of image themselves. So therefore we can ignore the labels, right? Now we have to we can normalize the images. So our pixel size value between the 0 to 256. So we have to also, we have to transform into the appropriate -1 to plus, right? And then so we are first, let me normalize those things, right? So we are going to normalize we have to taking here the 127 into 127. So because we are going to normalize all these things, so we are written the code here, right? So now let me run this code, okay? So once now the minimum is -1 and maximum is 1, right? So we normalize this data, right? So so we transform into the appropriate -1 to +1, right? Now we are going to add the channel dimension, okay? So originally the image shape is 28 by 28, but we are add more one dimension representing by the grayscale channel. So now your shapes become into 28 by 28 by 1. So we have to put the axis equal to 1. So we are going to expand the dimension here simply, right? So we are using here expand method to just expand the dimension here, right? So it will become 28 by 28 into 1, right? We got this dimension. So finally you can see here the image size is 60,000 and it will be 28 into 28 by 1, right? We got these things. So once after that we have to create a TensorFlow data set, okay? So we have to create TensorFlow data. We shuffle the training data, we add them, we divide into the different batches. So our batch size, you can take anything, but we are going to say the batch size is 128, because this during the training the GAN process the batch in the repeated way. So we are taking the 128 batch. You can also take the 64 batch or like 224, but we are going to take the batch size equal to 128, right? So we have completed this batch size, right? After that, we have to build the generator. Now we fix everything. So because we are going to build a generator, so our generator will receive the random vector. So I will use the latent dimension is 100, okay? So that means the every generated image begins with the 100 random number, right? So this variable represents the size of our latent vector. So now we are going to build, first we'll write here, then we build the generator. So first we are going to define the latent dimension, right? So it's 100 is use the, because every time generated image begin with the 100 random number. So now we are going to build our network, right? So for building the network we have to import this TensorFlow. We have to use the TensorFlow class. Then I have to also add the different layers. So let me write the code, then I will explain each and everything here, right? So we are writing here this code, okay? So we are coming on the top here, right? So now we understand why we are writing this code like this, okay? So here, first thing is I have created the sequential model, right? So we can see here we created the sequential model here, keras.sequential. So we are define the function build generator. Inside we are creating the model, sequential model. So this model represent our generator. Next we are use this dense layer, right? For that's why we have written this here model. This is a dense layer, and we have defined the everything here, the input shape, latent space, and our also define this dense layer. this dense layer converts the 100 dimensional latent vector into the larger representation. Then we have to use this batch normalizations, right? So it's a help the stability training, right? Stabilize the training. Now next we have used the leaky ReLU. So leaky ReLU is an activation function. They reshape the output. So finally we can reshape the output as a 7 into we reshape the output into 7 into 7 into 256, right? After that we have to use this conv2 transpose. So this is the one of the most important layer used for the image generation. So con2d transpose allow us to increase the spatial dimension. So now we have to generate a 7 by 7 feature map, right? Then we create it by eventually we can reach it into the 28 by 28, and finally we produce the output channel because MNIST image are the grayscale, and we have to use this 10h in the final layer. Okay, so you can see here in the 10h we have used this 10h in the final layer, right? We use the activation function in the final layer, right? So let me run this code. Okay, after that we have to create the generator. For the generator we have define one function here. We have written this Python function here, build generator. So now we are going to create this generator. So you can simply write here, see this function is build generator. We define here the build, you can see here the build generator function we have used here. Inside the build generator we have everything written here, right? Every layer we have written. Now we are going to just run this code. So you can see here we got this, finally. So you can see we got the all the details here, right? In the summary, in the generator summary we got the everything, right? So we have created the generator and we print out its architecture. Now we are going to visualize the untrained generator, right? So how can we visualize? So we have to generate, before generating the image, before training we have to generate the random noise. Okay, and we pass through the generator, and the output should be saved by the 28 by 28, right? And but remember the generator has not learned anything yet, so the image is essentially look like a random noise, right? So how can we see that? So let me write to print those things. So you can see here we are going to write the code here. So we are define the latent scale here, yeah. So putting the 1 into 28 into 1, right? So now we have to visualize thing what we have written here. So we have to visualize. So our generator produced before training, so it's like a digit, but but that was completely expected, right? So now we have to interesting parts begin, when we are going to train our generator. Still now we have not trained our generator. Now we have to only want to check the before training we are doing all the things. We have created a generator, we have checked the architecture. Now we are going to display the image, how it will like look. Okay, so you can see the image will be look like this. So this is just a random noise. Okay, there is no image, right? Before training we have just used this random noise here. Okay, so now let's important part is we are going to build a discriminator, right? So let's build the second network, so discriminator. So discriminator receive an image and output will be the single variable. So let me write here we are going to build the discriminator. So till now we have only built the generator. So we have to build the discriminator. Okay, so we are writing here, right? So we are building the discriminator. Okay, so for the same way we have to write the code. We have to use the Keras sequential discriminator, right? So everything we have to write like generator only thing. Okay, we have to also use the conv this conv. Okay, so discriminator use the convolution layers with this layer extract the visual features from the image. And also we are using the leaky ReLU for nonlinear learning, also drop out for the reduce overfitting. After that we are extracting the image, right? So for that we are going to write here. Okay, so let me write those things. Okay, fine. So now it's working fine here. Now we are moving here, we are moving to just build our discriminator. Okay, and then we will so we have to check the discriminator function is working properly or not. So let me write here to check the code like to similar like to generator. So now you can see here we got the final architecture of this discriminator, right? Similar to this is the architecture of discriminator and this is the architecture of generator, right? We have also written the code like similar to the for we have written code for the generator, and similar we have written code this discriminator, right? We got the both architecture. Now we are moving to the next step. We have to add the loss functions, right? So there is a concept of loss in binary loss entropy. So we have to define the binary loss entropy. This loss measure the how will the discriminator distinguish the real and fake images, right? So we have to define here the loss entropy, right? And because discriminator output logic instead of probability, you have to use this logic equal true, right? So let me write here this code. Okay, loss entropy we have written, and also we have used for we have to also check the discriminator loss, right? So we are going to write one function for discriminator dot, because for the real image our target is 1, but for the fake image the target our target is 0, right? So that's where we are going to define the discriminator loss. Okay, because the total discriminator loss is the real loss plus fake loss, right? This is the total discriminator. That's why we have to going to define here the total loss. You can see here this is the discriminator loss. Here we have defined the real output plus fake output, right? So we are taking the real loss, that is a cross entropy we have defined here, that is a cross entropy, and after that we have to also create the fake losses, right? A fake entropy, right? So we have already defined our entropy here. So after that we have to also create a generator loss. So similar way we have to use this uh, as we have to also carefully write for the generator loss, and we are labeled the generator image as a 1. Why we are writing 1? Because the generator want discriminator to believe that a fake image are real, and this is the key adversarial mechanism, right? This is the main adversarial mechanism, adversarial, right? So let me write these things. Okay, now we have this part is completed. We have achieved till this adversarial mechanism, right? Now we have to use the optimizer, right? So we can use the Adam optimizer for both network, because we use a small learning rate, right? So a small learning rate like 0.0002, like this. So this discriminator and generator have a separate optimizer. So this is important because we have two independent neural network. So we have to write a optimizer. We have to write the optimizer for this Adam optimizer, right? For the both network, right? So we are going to use for the both network. We are using this Adam optimizer for the generator optimizer and for as well for discriminator optimizer, right? So now this part is completed. Now we are going to build for the training step. So we come to the heart of this GAN, the training step. So this is where the generator and discriminator compete, right? So here we have to write the training. So we have already defined, we have to define the functions like a training step, okay, and we have to also write, write the, we have to generate. We have to just function represent one training step. Then we have to generate the random noise. Okay, so let me write this code here, right? So first thing we have to define, first we have to define, we generate the random noise. This noise will give the generator, and then we create a two gradient type object, right? And once we one will track the generator, another will track the discriminator, right? So let me write the code here. So you can see here we have defined here train steps, right? We are going to define the noise. It will contain the batch and latent dimension. Then we have to use this gradient type, right? Okay, so let me run these things. Okay, we have written for both, you can see here we have written for the real output discriminator, fake output discriminator, right? And we have also defined the this loss. Okay, disk loss and the discrimination loss and generative loss. Okay, so the generator will create the fake image here, and we will pass the real image to discriminator, and we also pass the generator image to discriminator. So then we calculate the generator loss and we calculate the discriminator loss. So next we have to create a gradient here, right? You can see here we have created a gradient here. In this code you can able to see we have created a gradient here, right? Here we have to create a gradient here, right? So what is the gradient? So finally we update, we have to calculate the gradient. So finally we update the generator parameter, and we have to update the discriminator parameter, right? So now we are going to generate the sample image. Okay, this training is now training part is completed. Now you can see how can we generate the images, right? So let me write the code for the generation for generating the image. So you can see here we are writing the max number of sample is 16. We are sending the random number, and we have given the number example and the latent dimension, right? So what is the meaning here? Why we return? I am creating the fixed site random seed. So this is very useful. During the training, we can use the same random vector in the repeated way that allow us to just visually compare the how generator moves, right? So we have to take the we have to this functions take the generator to output. So again we have to define one functions to just generate and plot the image, and we have to also use the text input, right? And we have to just convert the normalized pixel value into the normal range, and it will display the 16 generated image, right? So I'm going to write here, because the number sample is given here, so 16, right? So generate we are going to write for generated and plot, right? So after these things, we have to train the GAN, right? So training, you can first as an ANN, CNN, RNN, we start the training with the epoch, right? So finally we have to, you can use the any epoch. For the every epoch, the iteration through the entire training data set. For each batch we execute the training step, we calculate the generator loss, we have to calculate the discriminator loss, and this will store all the losses. So now we are coming to this training, going to train the gen, right? So I'm writing here in the text. Let me write here in the form of text. We are going to train our GAN model, right? So for training, we have to define the epoch. Then we have to define the generator loss, and we have to define the discriminator loss, and we have to we have to go up to. So epoch, for epoch it will take the little bit time, so I can reduce up to 20, because it will take some time here. So let me write this see, because we are written 20, so it will go up to 20 iteration, right? It will take some time, but still we are using the GPU, so it will within the 5 to 6 minutes it will going to complete. So it will, inside this code, you can see inside the code here. So we finally going to train our GAN. So we using this 20 epoch. So every epoch will iterate through the entire training data set. Every batch will execute our train step. We calculate the generator loss, we calculate the discriminator loss, then we store those losses, and finally 5 epoch we generate the image. So this allow to visually just absorbing the learning process, right? So as the beginning, the generator produced the random number, in that is this training part, the training is going on. You can see this is the epoch 1, this is a generator loss, this is a discriminator loss, right? So what is happening inside the training? So the discriminator can easily identify them the fake, right? First thing, the generator produce the random number, the discriminator can easily identify the fake, but the training continue, the generator start learning the structure of handwritten digit. So you should gradually see the shape appearing, right? Eventually the generator can produce the image that look like the handwritten, right? This is the power of adversarial learning, right? And after that, we have, once we complete the training, so we can see the visualize our how many loss we have, how many loss we got by this discriminator losses, right? We can also check the loss of discriminator and generator, right? So after this training, we will visualize the how much will be loss got in the both cases, right? Because we can, this is a very important point, because this GAN as a lower lower loss does always means better generator image, right? So this is a different may standard from the previous supervised learning. So GAN is just training competitions, right? So let complete these things, then we plot the loss visualizations. So first we complete this 20 epoch, right? So in the, you can see here in the fifth epoch we got this number like this, but still we have a discriminator loss. You can see the discriminator loss is 1.3, 1.3, then it's come to 1.27, 1.23, 1.228. Here is also, you can say, generator loss is starting in the 0.71, 0.76, 0.82. So you can see here, right, in the, you can see in the after, yeah, after 10 epoch we got this image, right? Still the training phase is going on. So after the 10th epoch, you can see we are able to see this is a 9634. So it means our we are able to see, generate the new data set here, right? You can see we are, so now we are in the 11th epoch. Okay, then we got in the 12th epoch. So you can see here the loss is, discrimination loss is decreasing, right? So we will see in the next plot, like what is the losses, how many we losses during the training again. So we can see by the graph. Right now in 13 loop 13 epoch. Okay, so let's complete this all the 20, and then we can also see the final image generations. Okay, so we can see the how many image generated, our final images. So these images are created entirely by the generator, so they are not copied from the training data set. So this module I learned something, so it's a representation and visual distribution of digit, right? So we can also see all the things here. So first let me complete this a training part, then we able to visualize the different losses. Okay, so now we are in 16 epoch, right? So you can see here in the 15 epoch we got the clear things like 4, this is 9. So it means uh, we are able to create the new data set. We are in the 17, and now we are writing in meantime I'm writing here the, we to check the, we are going to, we have to check, we have to plot the generator losses, we have to check the discriminator losses, right? And at the x-axis will be epoch and the y-axis will be losses, right? So we have to check like in which epoch how many we loss we got in the training GAN training losses, right? We have to just compare the discriminator loss and the generator loss, right? So in the 19 we got here, so you can see the loss is decreasing, right? Okay, so this 20 epoch training is completed, right? Now we are going to, you can see we almost we got the very good result here. So now we are going to check the how much losses we received here, right? So you can see here, this is the, this line is the, this yellow orange line is a basically a discriminator loss, and this is a generator loss, right? So after this loss, now we are able to visualize the generator or discriminator loss, right? So now we are going to check the final image generation, right? So we are going to just check the, so let's generate our final image, because this image are created entirely by the generator and they not copy from directly to a training data set. So it means the model has learned a representation of visual distribution handwritten digit and use the random latent vector to generate the new sample. So how can we check those images? So let me write here the code. Okay, so let me write those things here. So you can see the generated image and the plot images. So you can see here, so finally we got this final image, right? That is image is generated by the generator, right? So it means it use the random latent vector and generate the new sample, right? So now we save the generator. Okay, so we can also save, this image, we can save it. Okay, we can increase our image size. In the initially we have a 60,000, so we can also save these images here. So we are going to save the generator, save into the image GAN. We have finally we save this into the our training data set. So now we are going to load and generative new images, right? So how can we write? So now we are going to loading the training data, loading the generator. Okay, after that, I will generate the new random latent vector and pass it to the train generator, because generator has learned during the training it can create a new digit like images, right? So you can see here, I'm going to write here, right? So loaded generator, same thing here, loaded generator, you can see the result here. Okay, So now you can see we got the result like this. Okay, so finally with the our generator, we have train our generator. So now train our generator is able to just, because we are loading the training generator and generated a new random latent space. So now I pass to the train generator, because the generator has already know during the training, and it can create the new digit like image, right? So now let's summarize what we learned today. So we stated the fundamental of generative AI. Then we understood the what is the gain. Then we learned about the generator. So and then we learned about the discriminator, and we also understood the what is the adversarial training. Then we implement the DC GAN using the TensorFlow. Then we train it on the MNIST data set. We finally generate the new image. So this is only the beginning. The same concept can be executed to much more advanced architecture. For example, we can also use the style GAN, cyclic GAN, WGAN GP, conditional GAN, image to image translation, right? So we can also use anything. You can see here, in a custom, yeah, this is the custom data set. If you see the architecture here, so finally, what kind of thing we have completed here? So first we took the real data things, right? So in the entire MNIST project, you can see here we perform this workflow here. So first we took the real images, then we performed the data cleaning or normalization. We performed the data augmentation. We use the generator, fake images, discriminator, fake. Then we perform the adversarial training and generated image, and finally we also plot the loss curve evolutions, right? So with this step we have performed here, we can also build a GAN for synthetic and medical image generation in the upcoming project, right? So if you found this tutorial useful, then you subscribe the Think Lab by Saurabh. And thank you for watching and happy learning, and see you in the next video. Thank you.